Hi everyone, it's Dr. Linder. In this next section of neurology, we're going to be looking at brain, and we'll cover cranial nerves in another section, but let's talk about some of the main parts of the brain. The brain is really important when we talk about embryology. Remember, the neural system is the very first system that forms. It forms somewhere around day 18 or so. It's not called the brain, it's not called the spinal cord, but embryologically, I believe they call it like a notochord. But from that, the brain and spinal cord does develop. So from a sagittal view, when we look at a cross section of the brain here, but we look at it cutting it in half, so we're looking at half of a hemisphere, that it's a pretty large organ. It weighs about 3 pounds, and it has many functions. It's involved in sensation, your memory, your emotions, your decision making, your behavior, your hearing, seeing, your ambition, your drive, breathing, heart rate, balance, coordination. It does so many different things, and each of these centers of the brain is responsible for a different type of function. Okay, but for now, let's take a look at some of the main parts. So when we're looking at the brain from the lateral view or the side view, one of the first things that we have to ask ourselves is, where's the front and where's the back? Okay, so the way you know what's anterior and what's posterior is you have to find the cerebellum. The cerebellum is always on the posterior part of the brain. So we know that back here is posterior. We know what's on this side is anterior. So once we know that, then we could say, okay, here's the frontal lobe of the brain. We know that back here is the occipital lobe, right there in green. That's the occipital lobe. Then we have a temporal lobe near the temporal bone. Right, if you think back to osteology, didn't we have a frontal bone? Then we have a temporal bone. Then we have an occipital bone, and then we have a parietal bone. Well, deep to those bones are the lobes of the brain. So there's a frontal lobe, a temporal lobe, an occipital lobe, and a parietal lobe. Those are the main lobes of the cerebrum. Okay, those are the main lobes of the cerebrum. Don't confuse cerebrum with cerebellum. They're not the same thing. Cerebellum is really involved with balance and coordination. An important thing to notice is that in the pink right here, where we have our frontal lobe, and then over here in the purple or lavender is our parietal lobe. Between those two, there is a sulcus called a central sulcus. That central sulcus is this indentation, this groove right here. It's called a sulcus, but it's called a central sulcus. It's right down the center. And it's the clear delineation between this strip, this dark pink, and this strip, this dark lavender. The one in the front is called precentral gyrus, and the one in the back is post-central, right? Pre comes before and post is after. So pre is in the front, post is more posterior. Precentral gyrus, post-central gyrus. Precentral because it's in front of the central sulcus, post-central because it's behind the central sulcus. From a functional standpoint, they're really important. Precentral is where all of your motor information begins for all of your muscles and moving all of your extremities, whereas post-central, that's where all of your sensory input, ends up. As it ascends up your spinal cord, it's going to finally synapse at the post-central gyrus. And what I'd like for you to look up in either your book or if you want to Google it, you're going to look at homunculus, the term homunculus, H-O-M, homunculus. You're going to see a real funny looking picture of a person that's got like really big eyes, really big lips, really big hands and fingers, and it's going to indicate that the parts that are the most sensitive in the body are going to take up the most neurons in the brain. Like the lips and the fingers are highly sensitive. You can move your pinky ever so slightly so that in the precentral portion, the fingers and the toes and the eyes and the facial muscles and the lips, to move those things ever so slightly takes a lot of control and power. That's going to take up lots of neurons within the brain. So if you look up homunculus, you're going to see an individual stretched over the precentral gyrus and a person stretched over the postcentral gyrus, and it looks really unusual, but the visual helps you understand what parts of the body are going to occupy more neurons in these two parts. All right, so we have the cerebrum, we have the cerebellum, and then last we have the midbrain. And the midbrain is made up of the medulla. I'm sorry, not the midbrain, the brain stem, my bad. The brain stem is made up of the medulla, which is here, the pons, which is here, pons means bridge, and then there's a midbrain, which is just a little bit higher. It's going to be right here, but it's being blocked by this. So you're going to have the medulla, the pons, and the midbrain. That's part of your brain stem. Let's see if we can show it in this picture here. Here's the brain stem made up of the medulla, the pons, and the midbrain. Okay, medulla, pons, midbrain. Here's the cerebrum. Here's the cerebellum. So now that we see the cerebellum is back here, we know that this is posterior and this is anterior. So you know that this is the frontal lobe, this is the parietal lobe, this is the occipital lobe, and right here in the center, which we couldn't see from the other view, is an area called the Diencephalon, which is thalamus and hypothalamus. Thalamus is really important. All of your sensory input that comes into your body will be relayed into the thalamus. All of the sensory input that's relayed into the body, it's going to come up and it's going to synapse right there in the thalamus. All the sensory input except the sense of smell. The sense of smell does not go to the thalamus. Your hypothalamus, you're already familiar with. Why are you already familiar with the hypothalamus? Because when you covered endocrinology, when we talked about endocrinology, there's a link between the hypothalamus and our pituitary. So in this picture, here's the pituitary. Here is your hypothalamus. So you have your hypothalamus right here. There's your infundibulum, or the stalk, and then there's your pituitary gland. Okay. Here's your brain stem, medulla, pons, and midbrain. And in the back is your cerebellum. The frontal lobe is controlling your ambition, your drive, your emotional state, most of your movement, the initiation of movement from your body is coming from the frontal lobe. Your temporal lobe is where your hearing is going to be relayed to. Your occipital lobe is where your visual center is. When you slip and you hit the back of your head against concrete, you can go blind. Baseball bat to the side of the head, you can go deaf. Concussion to the front of the head, this is when people's personalities change, right? Parietal lobe is all about sensation. This is when people have disorders to the parietal lobe, they'll say, "Doc, look at my left leg. It looks fatter than my right leg. Look at this calf. It doesn't look like that calf. Doesn't this arm look swollen compared to that one?" And when they're really not, because objectively you can measure them, and when they're the same, but yet the person perceives it that way, there's a parietal lobe imbalance. Here on this view, now you can see the cerebellum here, so that's posterior. Here is the central sulcus going this way. So once you find that central sulcus, there's your precentral gyrus and your post-central gyrus. This is your motor cortex. This is your sensory cortex. Frontal lobe, temporal lobe, occipital lobe, parietal lobe. You can see the medulla down here and the pons. Again, you can't really see the midbrain. It's being blocked a little bit. So this is the central sulcus going this way. There's a lateral sulcus going this way. That's a lateral sulcus. Okay. So here on this picture here, we're looking at the brain, and we're looking at the brain stem. So this is the medulla, this is the pons, and inferior to the medulla, now we're at the spinal cord. The cerebrum, you heard me use the word sulcus before, and gyrus. So here's a gyrus. Those are like the hills or the mountains, and the valleys are the sulcus. Okay. Let's talk about some of these fissures here. So right there, see the green line showing up on the left there? So that's the longitudinal fissure. The longitudinal fissure is what's going to separate into a right and left hemisphere. That's it. Then we do this one, which I can do again down below, so we see it from two different angles. That's going to be your central sulcus. The central sulcus. And what did we remember about the central sulcus? Well, there's a precentral gyrus and a post-central gyrus. Here's your precentral gyrus, and there's your post-central gyrus. Precentral is your motor cortex, post-central is your sensory. Again, make sure you research the homunculus. It'll help put it together. Okay, right here is the parietal. The line didn't really show up in the right place. Should be like right there. That's your parieto-occipital sulcus. That's between the parietal lobe and the occipital lobe. It's the parieto-occipital sulcus. And then right there, that's your lateral sulcus, right here. Your lateral sulcus. That's going to be between the temporal lobe, right here, temporal lobe. Now, in terms of left and right hemisphere, this is left, this is right. You've heard of some people say I'm more left-brained or I'm more right-brained. So when you have left brain dominance, that's more linear. More linear. That's language, numbers, science, rationale and reasoning, sign language. So the left is more linear, numbers, math, science, reasoning is left-brained. Your right side is more artistic and creative, more musical, more art, space and pattern perception. Like some people can look at a room and go, oh, the couch will look better there, or a nice picture and plant will go there, or they color coordinate very well and know how to dress and match everything, where some people are really bad at that, right? It tells you which brain, what side is more dominant. When we're born, we are right side dominant. It's important because babies have to be able to recognize facial expressions. They need to recognize faces. They can recognize who the parents are or not. Right side gives the ability to generate emotional content to when the person speaks, right? When you hear me lecture, you'll hear an affect to my tone and I change my voice and I try and make it engaging. But then there are some people that speak this way, and when they talk, there is no emotional content to it. It helps you understand that the right side of the brain is not working too well. People that speak this way tend to be very good at math and numbers. Okay, hopefully you see the connection there. So left and right side of the brain. Now, what connects the left and right side of the brain is something called the corpus callosum. The corpus callosum are these group of axons that connect the left and right brain together. And females have a much, much stronger connection between the right and left brain than do men. It's just in the wiring of it. Okay. When there's damage to the left side of the brain, let's say there's poor oxygen or blood getting into left side of the brain, this results in something called aphasia, which is the inability to someone to speak properly. We've all seen the person on the news, the newscaster that's having a stroke on TV, where they start babbling the words, they're not making sense, and then they just drop. That is a stroke, typically to the left side of the brain, causing aphasia, the inability to speak properly. When we look at brain waves, right, there's a ways of studying electrical conduction to the brain. These are brain waves. And I'm not necessarily going to test you on what this wave looks like, but we can hook up these electrodes to an individual's brain and get impulses and readings. It's called an electroencephalogram or an EEG. An electroencephalogram is able to measure brain waves, and the different waves are indicative of, if, for example, if we see the alpha waves right here, you'll see this when a person is awake, but in a restful state. Now, if they're under intense stress, we're going to see theta waves. That means the person is under emotional stress. Right now, you may go back and forth between theta and beta because you're concentrating and there's lots of mental activity. Those are beta waves. When they do sleep studies, they want to see delta waves. That means you're in deep sleep. Okay, I'm going to take a little break here, and then I'll come back and just talk about some of the coverings of the brain and a little bit of the blood supply there. Let me take a break here.